Hey Fred, how you doing? Have you had a good day at school? Good stuff. Right, today we're gonna crack on and have a lesson about stars. So first of all, I just want you to tell me everything you know about stars and anything that springs to mind. It could be anything you find interesting, um, or any questions that you have too. And you can use these pictures as a bit of inspiration as well. So just for the first few seconds, just have a little go at writing them down, nice and relaxed. So, well done for doing that. Um, so, should we go through what you had? Yeah, they're definitely constellations. They're really good. Today, in what we're going to be learning, we're not going to be talking about that too much, and we're going to be helping you if you are hiking through the wilderness and you didn't have a map or a phone. But what else you said? Our sun is a star. That's very true. And the top left picture that you see there is the sun, and this is what we call a main sequence star, which we'll be talking more about in a little bit. Um, and then other things which you didn't have, which are from the pictures here. That top right one is a black hole, which can happen at the end of a life cycle of a star when they're really, really massive. And then that bottom right, nice looking picture is a nebula, um, which is just a cloud of dust and lots of hydrogen. And this one is actually the Crab Nebula, which it's called a crab because the person who found it said it looked like a crab. Can't really see that. But anyway, moving on, we'll crack on with the aims of the lesson. And the aims today are to understand the reactions inside a star and the forces that act on it, and then also understand the different stages of a star's life cycle and what influences the forces have during that life cycle. And then part of that aim will also be to understand the different routes that a star may take and what property this depends on. Amazing. So have you got any questions on them? No? I'm sure you will throughout. But yeah, let's see what's going on. So we have a main sequence star here. This is a star just like our sun, and what is in this diagram here is just the different arrows which represent the forces. So you have arrows here which are pushing against each other, and you have gravity acting inwards, and then a force of pressure acting outwards. So do you know much about gravity? Can you tell me anything about gravity? Yes, it's a force of attraction, and it keeps us here on Earth, which is pretty handy so we can walk around. But then anything that has mass creates a gravitational field, and stars are no different, and this is compressing inwards. But with the sun, it doesn't collapse in on itself under the gravity, because it's balanced by another force called pressure. And this is created in the middle of the star by a reaction called fusion. And do you know anything about a fusion reaction? No? Don't worry. Well, in the middle of a star, it is really, really hot, and understandably, and different elements, different atoms, nuclei fuse together. And in the main sequence life cycle of a star, hydrogen fuses together. So here you have a little equation on the left of your screen, just here, which is just an example of a fusion equation. And this is what's happening inside our sun at the moment. And it's two hydrogen nuclei that are bonding together. And they then form a helium and a leftover neutron. So this is allowed to happen because of the heat that is caused by all the mass and the gravity that is pulling all these nuclei together. And then these then in turn form larger elements. And the pressure that this causes from creating more heat and radiation and pushes out against it. Any questions on that? No. Okay. Well, the main thing to remember here is the two forces at play, which are fusion and gravity, and they're always working against each other to either create equilibrium or not. Okay, so here is a bit of information on the screen at the moment, but don't worry, we'll go through it gradually together. And again, we have this diagram over here, which is all about the forces that are at play inside the sun and other stars. So, as we said, we have fusion and gravity in there in a bit of a battle as such. And right now, they're responsible for the different stages of the life cycle of the star, and they create the changes between each step. So, from the start, we have this wonderful looking nebula here. And do you remember what I said about the nebula at the start? What it is? Yeah, that's right. Just a cloud of dust and gas and lots of particles that are in a bit more densely packed than usual. And then could you work out what would maybe change their arrangement at this stage? Yes, it would be gravity, and gravity would bring them closer and closer together. And then this is what moves them on to the next stage, into the protostar here. So this is just what happens when gravity brings all of the elements closer and tighter together. And from here, as the pressure from the gravity then causes the elements to come closer together, and the nuclei to come closer together, the gravity creates heat, and this heats them up and allows them to fuse. And that creates more heat and more pressure, and then balances out, as we said, until we get to main sequence star, which, do you remember what I said about that? Yeah, that's our sun. That's our sun, which is at this stage of its life at the moment, and then will be for another billion years. So then, can you see what happens next? Yeah, it takes two different paths, doesn't it? So from this, it depends on the mass of the star, and it all depends on how massive the star is, depending on what route it's going to take. And that is something that you should definitely remember, and they often ask in exams. So it's all about the size. And our sun is actually relatively quite small for a star. So our sun is going to take this path down here. And yeah. And other stars that are much more massive are going to take this one. So from here, the main sequence star either becomes a red giant or a red supergiant. And can you tell me why you may think this happens? What force creates this? No, it's not gravity. It's actually the fusion, in a sense, that causes this. And a way to remember this is that the stars are getting bigger, and you can see here that they're called red supergiants or red giants, which kind of makes them sound like they're much bigger than just a main sequence star, and they are. And this happens because the fusion of the hydrogen inside the core, it uses up all the hydrogen, and then the larger elements, which are just outside of this, then start to fuse as well. And this creates much more pressure and acts against the gravity even more until it gets bigger and it swells and it gets hotter because of these more energetic reactions. So that's what causes these red supergiants and red giants. And then moving on, if it goes from a red giant, it moves on to the white dwarf, and this is where the star, the smaller stars, they have used up all their energy, and the gravity then starts pulling them back in. And then it goes to a black dwarf, where the energy just gets so small and it becomes a very dense little object in the star. Very, very, very heavy. You won't be able to pick that up. And then on the other side, this is where the spectacular things happen. From the red supergiant, there's a big explosion, and this is called a supernova. And this then creates a black hole and a neutron star, depending on how massive it is. So this supernova is this big explosion that happens when the pressure gets so massive. From fusion, it grows so large, and then it has used up all of its fuel, and then the gravity just comes back in and compresses the star and all the mass into one, and causes this big explosion, throwing out loads of gases into space. And from here, this either creates a neutron star, which is this really, really dense little star that's spinning really, really quickly, and it's really, really bright for a little bit of time, and then, or it creates a black hole, which, do you know anything about black holes? Yeah, they kind of suck everything in and don't let any light escape, and they're pretty interesting. So here I've written out everything in more detail, and I'm not going to go through this all again with you now, but it'd be really good if you could look over this in your own time when you're at home and look at the different stages of the life cycle of the star. And it just tells you a little bit about each step. So one last thing on the supernova. So as we said before, that the fusion happens in the center of the star. This is going on between hydrogen elements, creating helium and another neutron. So all of the, as you can see here, all of the naturally occurring elements in the universe are created inside a star, which is quite amazing. So parts of yourself and myself. And then here the example is that the beryllium and carbon, which are larger elements, are formed in the supernova. And this can happen because of the intense heat and intense energy that's created at this time. And it fuses together more nuclei. So that's just another interesting point. Have you got any questions on that? Yeah, no, all of the elements that you could think of are created there. Okay, great. Lovely stuff. So on to the last slide, the dreaded. Just a little bit of homework. It's nice and easy. Just going through making sure that you've completed the objectives of the day. You can look back over the lesson that we've had, and definitely slide number 96 there, and to help you out, because that would be really useful. But no, well done for today, and I look forward to seeing you next lesson. Cheers, Fred. Bye.